This is Chapter 9, Access Control Fundamentals. As its name implies, access control is granting or denying approval to use specific resources. It is controlling access. Although access control is sometimes thought of as physical, such as hardware, man-traps, fencing, it is more properly the mechanism used in an information system to allow or restrict access to data and devices. Some access control terminology. The action of identification is a review of credentials, and the process on the computer is entering the username. The action of authentication validates credentials as genuine, and the user provides a password. The action authorization permits permission granted for admittance. And the computer process is the user is authorized to log in. And then the action access. Rights are given to specific resources, and the user is allowed only specific data. Other terminology is used to describe how computer systems impose access control. For instance, an object is a specific resource, such as a file or hardware device. A subject is a user or a process functioning on behalf of a user that attempts to access an object. And an operation is the action that is taken by the subject over the object. There are some roles involved. The role of owner. The owner is the person responsible for the information. They determine the level of security needed for the data and delegate security duties as required. The role of custodian. The custodian is the individual to whom day-to-day actions have been assigned by the owner. His duties, or the custodian's duties, are to periodically review security settings and maintain records of access by end users. And the role of end user is a user who accesses information in the course of a routine job. His duties are to follow the organization's security guidelines and not attempt to circumvent their security responsibilities. There are several access control models. An access control model is a standard that provides a predefined framework for hardware and software developers who need to implement access control on their devices or applications. The first we will look at is mandatory access control, or MAC. The most restrictive access control model is mandatory access control. This model is typically found in military settings in which security is of supreme importance. MAC has two elements, labels and levels. In a system using MAC, every entity is an object, laptops, files, projects, and so on, and is assigned a classification label. These labels represent the relative importance of the object, such as confidential, secret, top secret. Subjects, the users and processes, are assigned a privilege label, sometimes called a clearance. These levels are a hierarchy based on the labels, both for objects and subject. Top secret has a higher level than secret, which is a higher level than confidential. You can only access the levels if you have the correct label. There are two major implementations of MAC. The first is called a lattice model. A lattice is a type of screen or fencing that is used to support climbing garden plants. Different rungs on the MAC lattice model have different security levels, and subjects are assigned a rung on the lattice, just as objects are. Another implementation of MAC is the Bell-LaPadula model. Although this model is very similar to the lattice model, it contains an additional restriction not found in the lattice model. This protection prevents subjects from creating a new object or performing a specific function on an object that are a lower level than their own. The second model is the discretionary access control model, or DAC. The discretionary access model is the least restrictive. With the DAC model, every object has an owner who has total control over the object. Owners can create and access their objects freely, In addition, the owner can give permissions to other objects over these objects. The DAC is used on operating systems such as most types of Linux and Microsoft. DAC has two significant weaknesses. First, although it gives a degree of freedom to the subject, DAC poses risks in that it relies on decisions by the end user to set the proper level of security. A second weakness is that a subject's permission will be inherited by any programs that the subject executes. Trojans are a particular problem with the DAC model. There are two other models. There is the role-based access model, or RBAC, and the rule-based access model, also RBAC. Yes, it's confusing. The third access model is role-based access control, sometimes called non-discretionary access control. RBAC is considered a more real-world access control than the other models because the access under RBAC, role-based, is based on a user's job function within the organization. Instead of setting permissions for each user or each group, the RBAC model assigns permissions to particular roles in the organizations and then assigns the users to those roles. The rule-based access control, also RBAC, the rule-based access control can dynamically assign roles to subjects based on a set of rules defined by a custodian. Each resource object contains a set of access properties based on the rules. When a user attempts to access that resource, the system checks the rules contained on the object to determine if the access is permissible. So some best practices for access control. The first, separation of duties. This practice requires that if the fraudulent application of a process could potentially result in a breach of security, then the process should be divided between two or more individuals. This basically provides a cross-check and error check. Second is job rotation. Another way to prevent one individual from having too much control is to use job rotation. Instead of one person having the sole responsibility for a function, individuals are periodically moved from one job responsibility to another. Least privilege. Least privilege in access control means that only the minimum amount of privileges necessary to perform a job or function should be allocated. This helps reduce the attack surface by eliminating unnecessary privileges that could provide an avenue for the attacker. Implicit deny. Implicit deny in access control means that if a condition is not explicitly met, then the request for access is denied. Implicit means it doesn't have to be stated, it's just automatically denied if the conditions are not met. And mandatory vacations. In many fraud schemes, the perpetrator must be present every day to continue the fraud or keep it from being exposed. Many organizations require mandatory vacations for all employees to counteract this kind of fraud. For sensitive positions within an organization, an audit of the employee's activities is usually scheduled while they're away on vacation. So how do we implement access control? We do it through access control lists. You knew that was coming, right? An access control list is a set of permissions that are attached to an object. This list specifies which objects are allowed to access the object and which operations they can perform on it. When a subject requests to perform an operation on an object, the system checks the ACL for an approved entry in order to decide if the operation is allowed. Group policies is a Microsoft Windows feature that provides centralized management and configuration of computers and remote users using directory services, Active Directory. Group policy is usually used in enterprise environments to enforce access control by restricting user actions that may pose a security risk, such as changing access to folders or downloading executable files. Group policy settings are stored in group policy objects. These objects may in turn be linked to multiple domains or websites, which allow for multiple systems and users to be updated by changing a single group policy object. A local group policy object has fewer options than a group policy. Generally, a local group policy is used to configure settings for systems that are not part of Active Directory. Also, account restrictions. Another means of enforcing access control is to place restrictions on user accounts. Two of these are time of day restrictions, which can be used to limit when a user can log into the system. No more midnight working. And account expiration. Orphaned accounts are user accounts that remain active after an employee has left an organization, while a dormant account is one that has not been accessed for a lengthy period of time. These type of accounts can be a security risk, so you should disable any former employee account or account that's not being used. And authentication services. We'll talk about several. Radius is going to be the first one. Radius, also known as Remote Authentication Dial-In User Service, was developed in 1992. It quickly became the industry standard with widespread support across nearly all vendors of networking equipment. The word remote in Radius name is now almost a misnomer because Radius authentication, also dial-in is a misnomer. Radius is now used for more than just dial-in remote networks. With the development of 802.1x port security for both wired and wireless, Radius has seen even greater usage. A Radius client, typically a device such as a wireless access point or dial-up server that is responsible for sending user credentials and connection parameters in the form of Radius messages to a Radius server. The Radius server authenticates and authorizes the Radius client request and sends back a Radius message response. The strength of Radius is that messages are never directly sent between the wireless device and the Radius server. This prevents an attacker from penetrating the Radius server and compromising security. Radius allows an organization to maintain user profiles in a central database that all remote servers can share. Radius is widespread. Kerberos. It's a free authentication system developed by MIT, Massachusetts Institute of Technology. It's used to verify the identity of networked users. Kerberos is available as a free download from the MIT website. Kerberos uses encryption and authentication for security, and it will function under Windows 7, Vista, etc., even Mac OS and Linux. Kerberos is typically used when a user attempts to access a network service, and that service requires authentication. The user is provided a ticket that is issued by a Kerberos authentication server, much like a driver's license is issued by the DMV. This ticket contains information linking it to the user. The user then presents this ticket to the network for a service. The service then examines the ticket to verify the identity of the user. If it's verified, then they are accepted. TACACS, which stands for Terminal Access Control System. Cisco stuttered when they named this. It's very similar to Radius. It is an authentication service commonly used on Unix devices that communicates by forwarding user authentication information to a centralized server. Centralized server can either be a TACACS database or a database such as a Linux or Unix password file with TACACS protocol support. TACACS is a proprietary system developed by Cisco. And LDAP, which is Lightweight Directory Access Protocol. A directory service is a database stored on the network itself that contains information about users and devices. Directory services make it much easier to grant privileges or permissions to network users. The purpose of the X.500 standard was to standardize how the data was stored so that any computer system could access these directories. It provided the capability to look up information by name and to browse and search for information by category. The X.500 standard defines a protocol for a client application to access X.500 directory called Directory Access Protocol. However, the DAP was way too large to run on a personal computer. So, LDAP, the Lightweight Directory Access Protocol, sometimes called X.500 Lite, is a simpler subset of DAP. DAP and LDAP have some primary differences. Unlike X500, LDAP was designed to run over TCP/IP. making it ideal for internet and intranet applications. LDAP has simpler functions, making it easier and less expensive to implement. LDAP encodes its protocol elements in a less complex way and enables it to streamline requests. LDAP therefore makes it possible for almost any application running on virtually any computer to obtain, that means any computer, Linux, Mac, Windows, to obtain directory information. Because LDAP is an open protocol, applications don't have to worry about the type of server hosting the directory. However, a weakness of LDAP is that it can be subject to LDAP injection attacks. These attacks, similar to SQL injection attacks, occur when a user input is not properly filtered. And always remember to keep calm and document everything.